All right, so this is going to be the first of a series of videos that are dealing with comprehensions of various types in Python. I think this will be the longest video because we're going to kind of cover the basics of comprehensions, in particular list comprehensions, dictionary comprehensions, and set comprehensions. The other videos are going to be more or less special cases or special use cases of comprehensions that I end up coming across quite often when working with Python. All right, so let's go ahead and let's dive in and let's talk about comprehensions. And we are going to start off with a list comprehension. All right, so at this point, you're saying, well, what is a comprehension? I think the best way to kind of understand that is with an example. So let's think about kind of a standard way that we might use flow control to build a list. So let's say that we want to construct a list of numbers. In particular, we're going to construct a list of integers from 0 to 9. So I'm going to create an empty list called my numbers, and then I might say something like for number in range 10. Remember the range function, by default it starts at 0, including 0, and it goes up to, but not including the integer provided as this ending integer, at least in this use case, right? So just to show you that, shift tab within range. There's two common function signatures, so we're using this one right here. So we're just using range and providing a stopping value. So in this case, it will go and do the integers going from 0 up to, but not including that stop value. There's also a way you can define it with a start, a stop, and a optional step parameter. But for now, we are just using this one. All right, so what we will do, so I've got an empty container here, an empty list, and I'm going to say for number in range. And then for each one of those, I am just going to append that number to my list. And I am going to print, or just write out, since we're working in Jupyter, and it will always just print out that last variable at the end of a cell. So let's run this. All right. So we see that we do in fact have a list. It contains integers starting from 0 and going up through 9. All right, so this is perfect. This works. This is, completely valid code. But there's another way that you can do this that's a little bit more concise. And you can do this in particular with a comprehension. All right, and there's going to be different comprehensions depending on the container that you are trying to construct. So the first one that we're going to look at is a list comprehension. All right, so what I'm going to do is I'm just going to open and close braces, right? So this is how we would normally define a list. And if I hit enter, you can see it's just or shift enter, you can see that's just an empty list. All right, now watch what we can do. So let's think about our loop up here. So I've got an empty list here. What is the thing that we want to be recorded in this list? Just based off of this previous code block, we're going to be replicating this with a list comprehension. All right, so the thing that we wanted to be stored was the number. So I'm just going to copy that number here. All right, and I want it to be number, and well, which numbers? Well, I want it to be number for number in range 10. All right, so notice how we just kind of took elements from this loop construction that we had in that previous cell. So I'll just grab the thing that I wanted to store, that's first. And then I've got that iteration statement, so for number in range, and just put that right there. And now if I were to execute that cell, right, we get the same result. So this is a list comprehension that achieves the same thing as we had in this code block. All right, so if I were to store this as my numbers and put underscore LC, right, now we have a list comprehension that can achieve the same thing. All right, now a couple of benefits here. So first off, right, I mean, it's definitely brevity is a key benefit here, because definitely we used fewer lines of code when we did the list comprehension than we did up above here in this previous more verbose method of constructing that list. And you could make an argument that it is also a little bit more readable, right? So number for number in range, that seems pretty readable. I'm just popping that right into a list, as opposed to up here, I've got to construct this empty list for number and range and append. I think both of them are pretty readable, but still, maybe you find this preferable for your use case. Let's look at some other benefits. So what I'm going to do is I'm going to copy that first function down. or that, not the first function, but our first representation or method for constructing that list. And instead of doing range 10, I'm going to do range, let's see, 10 million. Using my underscores to help me quickly see the various digits. And what I'm going to do is I'm going to use that time it magic command to help me understand. Let's not do 10 million. Let's see. Let's start off a little bit more conservative. Let's do 100,000. So I'm going to say, well, time this execution, and this is going to essentially go over this many times and give me some type of statistical estimate for how long this construction is taking. So I'm going to actually go to 10,000. I'm trying to make sure I don't do something that's going to take 3 minutes here. All right, let's execute that. See when that returns. Shouldn't take too horribly long, but again, this time it is executing that several times to kind of get a statistical estimate of how long that construction is taking. All right, so it said, hey, for this one, I ran, 7 runs of 10,000 loops each, and it took about 195 microseconds, plus or minus 894 nanoseconds. All right, well, let's look at our list comprehension variant. So I'm just going to go up here, copy our my numbers LC down below, and also going to run that time it on that. And we need to make sure that we're doing this for the same range. So instead of range 10, range 10,000. And let's run this with our list comprehension. All right, so again, it's going to be running several loops. The number of loops that it runs could be different. So what this time it magic will do is it kind of will detect how fast things are running and adjust itself accordingly. So in this case, it took 168 microseconds, so it was a little bit faster. Let's crank this up just a little bit more. So let's go up to 100,000 on each of those loops. And then I'll run the regular construct, and then I'll run the list comprehension method. And notice, again, it noticed that it was taking longer each one of those iterations, so it only did 100 loops there. All right, we'll give that a second. So that one took 2.8 milliseconds. This one took 1.69. And this is pretty consistent. Sometimes I see a little bit more dramatic changes between the two, but it turns out that the Python maintainers have really optimized the underlying core code in the Python language to be very efficient for list comprehensions. So in addition to maybe the fact that we can have brevity, right? We only have one line. We can also, sometimes list comprehensions can be significantly faster. And I would say that this is significantly faster, right? So 2.8, 1.69. So it is significantly faster. It's not half, but if we were to say, well, okay, 1.69 milliseconds divided by 2.8, it's only taking about 60% as long as this more verbose format. And again, if you're doing this millions of times, right, that's 60% efficiency, or that 60% of the runtime, that increase in efficiency could be very, very meaningful. All right, so list comprehensions offer a lot of benefits in that respect. All right, so that's pretty much just the basic kind of core idea of not just a list comprehension, but a comprehension in general, right? So we've got some type of a container that we want to create, and we can come up with a more brief expression for creating that container, then writing out a multi-line structure for creating the container. All right, so let's continue on the theme of list comprehensions. I want to show you a few different variants, because you might say, well, this is great if you're doing very simple logic. I just want to build a list, right? So number for number in range 1000, right? Which I'll go ahead and tell you, you could do this even quicker. So if you've got range 1000, just to show you, right? So list comprehension, you might say, well, gosh, that was really neat, but I could have actually done this much quicker by just wrapping this in list, which is a reserved keyword. In Python, I'm passing it a range, and it will construct that and make it a list. For now, I'm only going to print out a few of these, so I'm just going to grab the first 10. All right, but it's doing the same thing, so it's giving me back a list. And if I were to time this, let's actually do that. Should be really fast. So let's give that a run. We'll wait for it for a second. Probably doing a lot of loops here. All right, so actually, surprisingly, didn't come out to be even faster than the list comprehension. So maybe there is, some even efficiency built into that. So somewhat surprisingly, just wrapping that thing in list, who knows what the underlying code is doing to build that. But so in this case, even list comprehensions have a advantage, but definitely this is a simpler syntax. All right, so you might be saying, well, we could have just wrapped it in list, so why use a comprehension? Well, you can do actually much more than just creating objects, right? So you can do filtering. You can put if-else logic in there as well. So I'm going to look at that now. We're going to look at a couple of different cases of that. So first off, let's look at building a filtered list comprehension. Okay, so in particular, let's say up to this point, we just said, well, we've got, a range of numbers and we just put them all in a list. But what if we wanted to be, do some additional logic, like only put the integers in the list if they're even integers? And that's what we're going to look at. So let's say even numbers is now what we're trying to build. And we'll first build it with kind of a traditional structure where we're using a for loop and we're doing an append. So let's say that we want to say, okay, maybe we'll look at the integers in the range of 1 to 20. So I could say for number in range 1 to 21 because it's not going to include that last one. All right, and what we want to do is actually only append to that even numbers list if the number that we're currently encountered is an even number. All right, so we could say, well, if, right, we've got to use a conditional here. We've got to make a condition. So I'm going to say if number, and then we'll use that modulus operator, divide that by 2, and see if there's a remainder. So if that's equal to 0, then we know that we, in fact, have an even number. So I'm going to pin that number to our list of even numbers, and then we will just print that list at the very end. All right, so this would be how we would do this logic with a traditional loop. Okay, so we've got our list of even numbers. Let's see how we could do this with a comprehension. All right, so I'm going to kind of build this. So I'm going to copy this first line. So here's my empty container, and I'm going to call this even numbers LC. Okay. All right, now what we want to do, the first item in this is going to be, well, what do I want to what's the value that I'm wanting to store? Well, I want to store number. All right. Well, which numbers? Well, each number for number in range, that. And then I want to do that if that number. So you notice I kind of grabbed the thing that I wanted to store, put that first, and then it's almost like I went down this structure and just put it in one line. So it's essentially going number for number in range 1 to 21 if that number is equal to 0. Now there's going to be a weird caveat. We'll see this very shortly, where we might. What if in this case we're wanting to filter the comprehensions? That's one thing I really want you to kind of pick up on, is I'm saying, okay, well, I only want to append these numbers if a certain condition is matched. So I'm essentially taking that set of numbers from 1 to 20 and I'm filtering it down to a smaller subset. There can be cases where you want the value you store to be different for different cases. And we'll have to use a little bit different syntax there, but we'll see it shortly. But now, here's the thing I want you to think in your mind. When we're filtering, when we're trying to control the entry or the storage of something in our comprehension based on a condition, right, we want that if to be coming at the end, right? So our conditional. And you can have much more elaborate conditionals. You can use ands and whatnot. But for now, we're just going to look at this case. All right, so we run that, and then there is our comprehension. So you can see that those two things are equivalent. Now again, I'm just going to pull this down and do that time it trick. Let's just see if we add a condition, if we're getting any big speed up. So I'm going to do time it. And let's make this, instead of range from 1 to 21, let's do range 100,000. All right, so we'll run that time it. All right, 2.65 milliseconds. And then I'm going to take our list comprehension and do the same. And then what do we do? 100,000. And then we'll put that time it up there. All right, so we still see a little bit of speed up, but not very drastic. One thing to note here is like the variability per loop. So that plus or minus, that's telling us like, you know, how much variability is in those run times as it executed all of those runs and those loops. So there is less variability. All right, but still a little bit of speed up. So, but that's how you would do a conditional, right? So if you're wanting to filter that list. All right, so we're going to look at one more thing in a list comprehension. Or actually, we'll look at two more things, right? But this will be, and then we'll move on to the other types of comprehensions. And a lot of the things that I'm showing you with list comprehensions will apply for the other types of comprehension. So if we were doing a set comprehension and we wanted to do a filtered set comprehension, you'd build it in the same way, for number, and then put that if statement, that conditional at the end. I'm just showing you with a list because we've just started off a list and I wanted to show you all those variants that you can do with conditionals. And then we will look at the other two types of comprehensions in pretty short order. All right, now one thing that I'm going to do to demonstrate this, so now what we've done here, this was filtering our comprehension. So we had the conditional at the end. Now what I want to do is write a comprehension where the value that we're storing depends on a certain condition, and that's going to be subtly different. All right, so, and I'll try to demonstrate this in a way that is as clear as possible. All right, so what I'm going to do is I'm going to rely on an external library. So in this case, this is going to be a library that's built into the Python standard library. Up to this point in this series, this Python fundamental series, we haven't talked about the standard library. I'm actually going to have a whole, another playlist that's looking at, not comprehensively the standard library, but some of the tools, packages, and functions that are available in the standard library that I tend to use quite frequently. So for now, this is going to look a little bit foreign. Don't worry about that. We'll see, more on the standard library and this library in particular in other playlists. All right. So what I'm going to do is import the random library from Python's standard library. And what I'm going to do is from that, I'm going to set the seed. So the random library has a lot of capabilities for generating random numbers. So for example, if I were to do random .rand int, I believe it's the right call. Now if I run that, let's see, I've got to give it 2 arguments. So let's say, what does it take? A and B. So I'm going to say 1 to 20. All right, so this generates random numbers. Now, watch what happens if I take this seed off. Every time that I go through there, right, it's generating a different random number. And sometimes that's exactly what you're looking for. But, a lot of algorithms that you'll use in practice require some type of a random component. And a lot of times you want those things to be repeatable. So what you can do is you can set a seed to make sure that that random number generator starts off at the same point. Okay. So if you generate a sequence of random numbers, which is exactly what we're going to do, you'll know that you're starting off with the same sequence, so it makes it repeatable. And it might help to hopefully ensure that the results that you're seeing are kind of what I'm seeing on my screen right here. Now, of course, these things are the seed could use some additional information from your operating system. So or other things, the algorithm that it's using to generate random numbers could actually change. So the numbers that you get might not exactly match the numbers that I get, but that's okay, right? We're just generating random numbers for the point of demonstration. All right, so that's exactly what I'm going to do. I'm going to make a list of random numbers. And for now, we're just going to assume that this is data we have. All right, and I'm just going to say for I in range 10, what I want to do is take random numbers and append rand int, and let's go from -20 to 1. All right, so I'm just generating a list of random numbers. All right. Now, just as a quick side note, I could have done this with a list comprehension just to show you that, since we're talking about list comprehensions, and we'll get a little bit more practice. So what would that code have looked like if we'd have used a list comprehension? So I'm just pulling down my imports. You don't have to import. You only have to import libraries once, but I'm going to probably keep that import statement, bringing that down as I go wherever I'm using that, just to, so you can see the complete code instead of having a random import random way up in this notebook, and then using it. I'm going to keep it pretty close by. So if we want to do this with a list comprehension, right, we could have done something like random numbers. Let me put a LC right there. All right, remember, what's the thing that we want to store in this comprehension? Well, it's going to be whatever this random number generator generates. So I'm going to put that call first, and I want to do that. How many times do I want to do that? Well, I want to do that for I in range 10. And then let me print the list comprehension here. Right, so we can see we're getting exactly the same. Right, so we could do this with, again, just building a list and appending it, or with a list comprehension. All right. Either way, this is what we want. I've got this random numbers, and let's say that what we wanted to do is take these numbers and we want to build a new list that includes the value that's stored if that value is non-negative. So if it's greater than or equal to 0. All right. And in cases where it's less than 0, we want to replace that with a 0. So basically what we're wanting to do is take these random numbers, and anywhere we have negative values, replace those with 0. All right. And you might say, well, why would we ever want to do this? We're not going to get into that here, but this is actually very similar to an activation function that's very commonly used in machine learning or neural network pipelines, called a rectified linear unit. Of course, there's going to be more efficient ways to do this, but just to kind of show you basically what it does, if you've got a sequence of numbers and you apply a ReLU activation to it, it's going to take any value that's less than 0, and it's just going to make that 0. So basically, that's what we're mimicking here. All right, so let's think about how we would do this with a traditional for loop, appending things to a list. All right, so I'm going to take non-negative. Whoops, let me spell that correctly. Non-negative random numbers. That's going to be the name of my container. All right. And then what we'll do is we'll say for number in our random numbers. All right. So for each one of those, we're going to say if the number is greater than or equal to 0, what we want to do is we want to append the number. All right. Else, if that condition is not satisfied, meaning that that number is negative, what we want to do is we want to append 0. All right. So we can run this. And there we go. So we see the -18, the -4, the -1. Those are all replaced with 0 in that non-negative random numbers list. All right. Now here's the key thing to note. Right. So previously, when we were dealing with conditionals, because you might say, well, this is just a conditional, right? It's very similar to what we saw previously, right? So I'm just going to scroll up just a little bit. When we were doing our even numbers, remember we were doing the conditional to filter what went into the list. All right. So in this case, we're only storing things if the number, once we take that modulus and get the remainder, if that's 0, if that remainder is 0. Right, so that was essentially like a gatekeeper of what got into the list. That is not what is going on here, right? So we're actually using our conditional if-else statement right here to figure out what is stored, right? So we're storing a value for each one of those random numbers, but it might be the number itself, or it could be 0, depending on whether or not that number is greater than or equal to 0. So whereas before, we were changing how many values were stored based on the conditional. Here, we're essentially changing the value that is stored for each one based on that conditional. That's a subtle difference, but it's going to actually change how we construct our list comprehension. All right. So how would we do this? All right. So non-negative numbers, right? We're thinking about what we've defined our variable that we're going to store in. I'm going to say LC right here. And then I am going to start with my empty list. All right, now here's the kicker, right? So what number do we want to store, right? Usually that's the first thing that we do. We go grab number and pop it as the first argument. But now the thing that we actually want to store depends on what condition is satisfied. All right. So what we want to do is, this is how we would write that. We want to store number if number is greater than 0, greater than or equal to 0, else we want to store 0. Right? So in this case, when the conditional is actually affecting what gets stored, this is how that syntax looks. Right? So number, if that number is greater than or equal to 0, else store 0, and we want to do that for each one of our numbers in random numbers. All right, so that is how we would build up that loop. All right, you can see we get exactly the same result. All right, so that's kind of the key difference there, right? It's like in this case, and again, it's very subtle. Is, you know, the other one, we were changing essentially the size. We were filtering which things actually get stored, right? Is the element going to get stored, yes or no, based on the condition? Whereas in this case, everything's going to have a value, right? For each one of those random numbers, something's getting stored. It's just depending on the conditional, is it going to be the number or is it going to be 0? And that's where that change comes in. All right. Now, you will note, let me just do a quick example. Let's see, because we have some of these things. Let's say that we have, let's see, let me take this, let's see, let's say that we have a list of characters. All right, and let's say A, B, C, and D. This is a very trivial example, but I do want to show you that Python will complain if you get this wrong, right? If you try to do the filtering, if you're trying to maybe filter that based on, you know, those values. So let's take a look at this. All right. So I'm going to say, well, what if we only want to, you know, we want to take, we want to figure out, are these characters A or B, and if not, we're going to put not A or B. All right, so very, very kind of simple contrived example. All right, so let's just kind of build out our looping structure here. So I'm going to say this is going to be our target characters. All right, and I'm just going to go ahead and build this as a comprehension from the get-go. All right, so we want to store the value. So I'm just going to put val if val, and I'm going to say in A, B. All right, and let's actually look at this in a couple different ways. For val in list of characters. All right, so what if we were trying to filter this list, right? So what if you only cared about A and B? You might say, okay, well, that's a case where we're trying to filter what actually gets stored in our target characters based on some condition, right? And you might say, you know, again, I've shown you two different ways where the filtering usually goes at the end, but what if you put it here? Can we use the logic here? So it's going to be val if val in AB for val in list of characters. Let's watch what happens when we try to do that. Gives us an error. Okay, so whenever you use this syntax where you've got the if statement before the iteration, right? It's gonna flag you. It's gonna say, hey, well, this is the thing that you're trying to append to this list, and you've got an if statement right here, but there's no else. So Python will complain if you put the if statement early in that comprehension, but you don't have an else. Right, so it will kind of help you there. Now, of course, if we were doing this in a filtering context, this would be perfectly valid, right? So in this case, if the character's A and B, it gets added, right? But we saw a minute ago that if we have it up front, we've got to have that else condition. And if we were to put the else condition right here, right, this is going to be, let's say, not A, but not A or B. Right, I do believe that this is going to complain as well. So let me look at this real quick. It looks like something, it doesn't like something. Let's give it a shot. Let's see what this does. All right, so yeah, it doesn't like that else. So Python's going to grumble if you get those things backwards, so that is helpful. But again, two different use cases. I know it's really, really subtle, but did want to make sure that I mentioned that here. All right, one last thing that I want to do, and this will be the last thing on list comprehensions, and then we'll look really, really quickly at dictionary comprehensions and set comprehensions, is show you that you can do nested comprehensions. Now, even though you can do it, doesn't necessarily mean that you should do it. So, one thing that, we've already seen, list comprehensions can be really nice. It allows us to take, like in this example right here, this was 1, 2, 3, 4, 5, 6 lines of code. And then now we've got that in a single line, which can be really nice. And it, different opinions, people will, some people think it's more readable. Some people might think you lose some readability. But again, a lot of people, it is a nice succinct kind of brief way of representing, or building a particular object like a list, dictionary, or set. You can do this with nested list or dictionaries or whatnot, but then to me the readability starts to suffer, especially if you go beyond a single nested level, so 2 levels. So let's look at an example to see what I'm talking about. So again, I'm going to use our random library. So I'm going to import random. Again, you don't need to import this every time. I'm just trying to keep everything together. And then I'm going to set that random seed equal to 0. And what we're going to do is we're essentially going to generate a matrix, right? So it's going to be a list, but it's going to be like a matrix represented as a list. So we're going to have rows and columns, and we're going to have a shape. So I'm just going to make a square matrix. Let's just do shape of 5. Make it somewhat simple. So this is going to be the dimensions. So we're going to have a 5 by 5 matrix. So we're going to have a list with 5 entries, and each one of those entries is going to be another list with 5 elements. All right, so I'm going to say, well, this is going to be my matrix. All right, and then what I'll do is I'll say for row in range shape. And for each one of these, rows, I'm going to create a new list. So I'm going to say this is going to be my row. This is going to be another empty list. And then I'll do for column in range shape. We'll do my row dot append, and what I'm going to do is just generate some random values from like a normal distribution. So the function for that in the random library is a Gauss. So what we're going to do is I'm actually going to round this. I'm going to say generate a Gaussian random variable. I'm going to round that to 2 places. All right. So what I do for each one of my rows, I create an empty list. For each column, I insert some random values. And then once we've done that for all columns, I am going to append the current row to my matrix. And notice here the indentation, right? So I'm generating these random values, putting that in row. And once I've got that row constructed, then outside of this for loop right here, I've got my matrix, and I'm going to do an append and put my row in there. Whoops. Fantastic. All right, so let's take a look, make sure I haven't fat fingered anything. There we go. So we've got our matrix of random values. So you can see if I were to look at the shape of this, or look at the length of my matrix. All right, it's got 5 elements. If I were to grab the first row, all right, so each one of those entries, so from 1, that's that. Now this is the second row, third row, and so forth. And then each one of those has 5 elements, right? So we've truly got a 5 by 5 matrix here. Now, again, you can do this with a list comprehension. So let's just see what that looks like. Again, to me, this is kind of teetering on the edge of, we're going to lose interpretability or readability. So, use at your own peril here. Again, A big thing about Python is the emphasis on readability and people being able to interpret what you do. And the most important person that you want to make sure can interpret your code is future you, right? So 3 months down the line, when you have to go in and edit this code, can you look at it quickly and say, okay, well, I understand what I was doing here. All right, but let's see how we can build this comprehension. So I'm going to take my matrix, right? So we're starting off the same way. I'm defining my variable, and I'm going to do a LC right here. Empty container. All right. What is the thing that I want to append? Now, this is where the trick is, right? So you might say, well, we want to append this random Gauss, right? Well, actually, in your matrix, think about each element in your list. Well, the first element is a row of essentially values. So you actually want to append not that random Gauss, but you want to append a list of random Gauss values. So what you actually want to do is you're appending, and it's going to be another comprehension. So what I'm doing is I'm saying, okay, well, I want to take round that Gaussian, right? And I want to do that for each column in range shape, right? So notice right here, this is your value, right? So it's a list itself, right? So you're going to be appending list into this. Right, so that's your value. So it's going to be round, random Gauss 2, for column in range shape, and you want to do that for row in range shape. All right, looks a little bit different. And again, this is kind of where I'm talking about the readability piece of this, right? So if I run this just to see, let's make sure we're getting. Oh, let me set my C, because you notice those two things don't look alike. So let me put my C, let me put the import statement, all of that. Let me put all of this right in front of it just to make sure that you can see that it's doing exactly the same thing. So let me run this one again. So this was our original, so 0.94, negative 1.4. And now if we do our LC, right, we're getting exactly the same values. We can actually check that and say, what is my matrix? Are the values in my matrix equal to those in my matrix LC? And that is in fact true. All right, so these two things are doing the same thing. Right, again, I think you know, this is kind of teetering on the edge of, okay, I've got to look at this a few times to understand what's going on, and this might be a more, interpretable, easy to understand view, but it can be done, right? One thing that I will say is if I do write these type of comprehensions, even though, you can technically write them on one line, I like to break them out. So I might say, well, okay, well, here's going to be the value. And I want to do that for row in shape. To me, this is a little bit more readable because I'm breaking those components over lines, right? And you can see that Jupyter's doing the nesting for me. So that's going to return the same result. All right, so we've talked about list comprehensions for a good bit, and we've looked at, how can we do filtering statements with conditionals? How can we use if-else logic to, change the values? And we did talk just briefly here about how we can do nested comprehensions, even though that might not be, the best thing to do from a readability perspective. It can be done. All right, so I wanted to go through real quick and just talk about other types of comprehensions like dictionaries and sets in particular, and this will go by fairly quick. All right, so let's say that we want to make a dictionary that contains the squares of, a set of integers. All right, so I'm going to make a dictionary. Let's do this as we did with our list comprehension. So if we were going to write this with a for loop, we would do something like, well, for number in, let's say, range of 0 to 21. All right, and if we're going to save the squares, so this is going to be the squares of the numbers from 0 up to 20, just integer values. Let me spell squares correctly. And I'm going to say squares for number equals number squared. All right, so that is our typical type of list or dictionary. So we in fact get those squares there. All right, and let's see how we could do this with a comprehension. So a dictionary comprehension is going to be very, very similar to a list comprehension. So what we do, I'm going to delete this here now that we've seen it. And my apologies if we hear something outside. It seems like someone's cutting the grass outside, but hopefully we get the video done before it gets too noisy. All right, so I'm going to say my squares, I'm going to call this DC. So here's our empty object. So we're starting off just like we did with our list comprehension. All right, and then with our list comprehension, we would typically next put in the value that we're trying to essentially assign to the list. In this case, we have a dictionary. So instead of single items, we have key value pairs. So we have to specify both the key and the value. So instead of just putting a single item here, we would do number colon number squared. So we've got the key and the value separated by a colon. And we want to do that for number in range. All right, so this works. All right, so those two things will be equivalent. So if I were to show you squares again, right, we can see it's got all of those integers, including 0 and their squares, and squares DC has exactly the same thing. So again, building a comprehension, it's basically the same recipe. We start off with what we want to store, and that depends on the type of comprehension that you're creating. If it was a list, we just stored one item. If it's a dictionary, we got to have keys and values. And then we have some type of statement that controls how we're going to generate those values that are going to be stored. All right, and finally, we are going to look at a set comprehension. Once again, I am going to use the random. So I'm going to say import random. All right. And then what we're going to do is, let's just say, first off, I'm just going to generate 20 random numbers from 1 to 10. So I'm going to look at this from a list comprehensions perspective. So I would do random and then do a rand int from 1 to 10. All right. And I'll do that for I in range 20. So it's 20 random numbers. So this is a list comprehension. Right, so you see that, hey, I've just generated, let me actually do the seed there as well. All right, so we've got 20 random numbers here, and notice that some of them are repeated. And that's really what I wanted to do, showing you this list comprehension first, was to show you, again, just emphasizing the difference between a list and a set. So in this case, when we build this list comprehension, we can have values repeated. So we see the value 7's repeated. Many times 3 is repeated. A lot of the numbers are repeated. If we were to do this same code and we wanted to generate that as a set comprehension, let me copy that. So the only difference from generating a list comprehension from a set comprehension is essentially the container. So those square braces indicate that we are generating a list. If we do curly braces, it could be a set or a dictionary, but if we're providing a single item, it's going to recognize that, hey, this needs to be a set, not a dictionary. And when we run that, we see that we only get the unique integers from that list. All right, so that was, kind of an overview of comprehensions. Hopefully you've gotten, kind of some insight into the basic recipe and the possibilities that are, associated with comprehensions. And again, you can do it for list, you can do it for sets, you can do it for dictionaries. Again, the key thing that I want to emphasize is there can be some real benefits to using comprehensions. In particular, you've got brevity, and then there can be some slight runtime advantage, even though with newer versions of Python, they're doing optimization. So I imagine that gap to get closer and closer over time. But the key thing is you've got to, really balance that with readability and interpretability. So when we did that nested list comprehension, right, it began to lose some of that interpretability. So we want to make sure that, we're balancing that. If it's more explicit, if it's easier to understand, having kind of that long form, I would encourage you to do that. All right, so I'm going to stop the video here, and then we will pick up in subsequent videos looking at some special cases of these comprehensions.